Toughness is measured with one of the most absolutely high-tech machines you'll ever see. It's a hammer. It is a literal hammer, a sledgehammer with a pointy end and a calibrated scale. I've got a anvil, swinging anvil, reed hammer. Here is the specimen that I'm trying to break that has a set dimensions, 10 millimetres square if it's a charpy test. Charpy, charpy, that is horizontal, with a predetermined crack, preformed notch in the middle. And then physically we start there, swing the hammer down, snap the thing in two, that absorbs energy. What energy is left gets converted from kinetic back to potential energy up the other side. If it stops here, there's the hammer on the other side. There's the height difference. That energy that it's been lost, that it hasn't travelled up, is just the energy involved in breaking the specimen. If it's a brittle specimen, then it doesn't need much energy and the hammer swings all the way back up here. If it's a really tough specimen, then it doesn't break and the energy's down here. If it's somewhere in between, then you can just measure how much energy you've used. That's toughness testing. That's engineering strain, engineering stress. That's toughness. Charpy, the specimen is horizontal and it's 10 millimetres squared by, I don't know, 70 long, with a notch in the middle. The other one, izod, it's vertical, and it's a 10 millimetre round bar with a slit cut in it that sits vertically. So an izod test, it's exactly the same machine, just with the specimen looking like that. That's your toughness testing and engineering stress strain.